This is the fifth CNC lecture of CAM 810S. Excuse me. Remember that CNC4 tools is part of this lecture and the next one. The topics: concept turn 250, the CNC lathe at the laboratory, coordinate system, sense of rotation of the spindle, points on a CNC lathe, turning tools, and tool holders for turning tools. The correct designation of the CNC lathe at the laboratory is EMCO, Concept Turn 250 TCM. EMCO is the manufacturer, domiciled in Hallein, a small town near Salzburg in Austria. Concept is the designation for a machine family with interchangeable controllers. 250 indicates the swing over bed in millimeter. T stands for turning. C signifies that the machine has got a C-axis, which is necessary, for instance, for eccentric axial drilling. And M means that milling operations are possible. For milling, we need again the C-axis and driven tools, so that milling operations can be done radially, as this example shows. Regarding machine components, please study and discuss page B1 of Concept Turn 250 machine description. Identify and discuss the components on the machine. The right-hand rule, with which you are familiar, applies also on CNC machines. Remember that the axis rotating around the x-axis is A, around the y-axis is B, and around the z-axis C. Seen from the point of origin of the coordinate system, A, B, and C axis rotate clockwise when the prefix is positive. In CNC lathe machines with slant bed or inclined bed, the tool is behind the z-axis, which is the main axis. The prefix is determined in such a way that the tool moves away from the workpiece when the prefix is positive. Looking at the workpiece, plus Z points to the right, away from the face of the workpiece. Plus X also points away from the workpiece. On Concept Turn 250, there is no Y-axis. It has got only a Z and an X axis. The sense of rotation of the spindle, seen along the Z-axis, and towards the center of the face of the workpiece, is clockwise, as shown by the blue arrow in the diagram. The sense of rotation of the C-axis is determined and looked at from the point of origin of the coordinate system. The positive sense of rotation is clockwise, as the red arrow in the diagram shows. The z-axis can of course rotate in both directions, positive and negative. This diagram shows the 4 important points on a CNC lathe machine. Point R is a reference point, somewhere on the machine. It is determined by the manufacturer and is approached only when referencing the machine after switching on. Its graphic symbol is a circle divided into 4 segments: 12 to 3 o'clock black, 3 to 6 o'clock red, 6 to 9 o'clock black, and 9 to 12 o'clock red. On part drawings and in books, the red color is replaced by white color. Red is only shown here to done an emphasis. Point M is the machine 0 point. It is a fixed point situated at the spindle face. Its graphic symbol are 2 concentric circles, also divided into 4 segments: 9 to 12 o'clock black, the rest red, or usually as in books or on drawings and diagrams, white. The next point is the workpiece 0 point W. Its graphic symbol also has 2 concentric circles, the inner one being black colored from 3 to 6 o'clock, the rest being red or white colored. Point T, also sometimes denoted with the letter N, is the tool reference point. Its symbol is a circle, which is black colored between 12 and 3 o'clock. More about the specially pointed W, that is the workpiece 0 point, later on. The next topic is turning tools. Let's start with a short repetition of edges, surfaces, and angles. The turning tool has got 2 cutting edges, a main cutting edge and a front cutting edge. The place where the 2 edges meet, the cutting edge nose, is not a sharp one, but is rounded so that it does not break under normal cutting conditions. There are 3 surfaces: the rake surface, on which the chip is formed, the main clearance surface, and the front clearance surface. Rake surface and main clearance surface form the cutting wedge. There is a clearly defined geometry on outside turning tools, denominated by Greek letters. Alpha is the wedge, the clearance angle, excuse me. Alpha is the clearance angle. Beta is the wedge angle. And gamma is the rake angle. Alpha plus beta plus gamma equal 90 degrees. Two more important angles are defined when we look from the top to the tool and the workpiece. Eta is the corner angle of the tool, formed by the main cutting edge and the front cutting edge. Kappa is the lead angle between the main cutting edge and the workpiece. The lead angle kappa is between 45 and 107.5 degrees. For easier understanding, the tools are shown in front of the z-axis, but they are of course exactly the same when they are behind the z-axis as on a slant bed CNC lathe machine. If the cutting tool is behind the z-axis, it looks like this. The arrows indicate the feed direction for turning of this contour. For profiles like this one, kappa, lead angle kappa, is 93 degrees, so that facing and contour turning can be done with the same tool. For recess turning, there should be a minimum secondary lead angle kappa n of 2 degrees. Observe that the cutting tool is again in front of the z-axis. Regarding the position of the turning tool relative to the workpiece, three types can be distinguished: the right turning tool, a neutral turning tool, and a left turning tool. The tool must always be looked at as shown in this diagram. We distinguish furthermore between tools for outside turning and tools for inside turning or boring. This is a choice of commonly used outside turning tools. Remember the way to determine whether they are left or right turning tools. This is a left roughing tool. And this is a left side tool. A neutral turning tool. And a right side tool. A cutoff tool. A left external thread tool. And a right external thread tool. These are commonly used inside turning and boring tools. A right roughing boring tool. A right boring tool for smaller holes. A right internal thread tool, 60 degrees for pitches between 0.5 and 1.5 millimeter. And the right internal thread tool for 60-degree threads, metric threads, for pitches from 1.75 to 3 millimeter. And this is a center drill. Twist drills of different diameters, which are of course also used on CNC lathes, are not shown here. This is the tool turret of Concept Turn 250 TCM, often also called revolver. On Concept Turn 250 TCM, 12 tools can be installed. 6 of them may be driven tools for milling. Tools are not installed or set up directly in the tool turret. They are clamped in specific tool holders. The up part of the tool holder shaft is a rack. The tool is clamped in the slot of the tool holder. The tool holder is inserted and fixed to the tool turret with a pinion, position 2, which moves the rack. Clamping is done in counterclockwise direction, as the arrow shows. Tool holders are standardized so that the tools can be set up outside of the machine and that the tools are interchangeable. European manufacturers use the German VDI standard. The number indicates the diameter of the shaft. In this case, 16 millimeter. This is a VDI 16 radial tool holder for outside turning tools. Quality tool holders have individual and adjustable coolant nozzles for the tool. This is a VDI 16 axial tool holder for inside turning and boring tools. Let's now have a look at Concept Turn 250 TCM tool holders. There are two main types of radial tool holders. This tool holder is used when the spindle turns counterclockwise. The FANUC T symbol for the counterclockwise rotation is M04. FANUC T is the controller software installed at Concept Turn 250 TCM. The tool is clamped upside down. This tool holder is used when the spindle turns clockwise. The FANUC T symbol for clockwise rotation is M03. Both tool holders have adjustable coolant supply nozzles. This is an axial tool holder for inside turning and boring tools. It has also an adjustable coolant supply nozzle. These tool holders are available with inside diameters of 6, 8, 10, 12, and 16 millimeter. Collet holders allow clamping of different sized inside turning and boring tools with cylindrical shafts. Coolant is supplied via a copper tube extension. EXS16 collets are available in sizes of 1 to 10 millimeter diameter. The same collets are also used on Concept Mill 105, the milling machine at our laboratory. This is a radial tool holder for driven tools. The shaft is VDI 16 also. The pinion engages to a gear in the tool turret, and power is transmitted to the collet holder by a bevel gear drive. EXS16 collets are also used here. Coolant is provided by an adjustable nozzle. This is an axial tool holder for driven tools. The pinion drives the ESX16 collet directly. Coolant is provided by a copper tube. It is clear that borings in the tool turret, which do not have a tool, must be closed by special closing holders. This is the end of CNC 5 lecture. Please do your exercises. And as an additional exercise, identify and discuss the tools installed in the tool turret of Concept Turn 250 TCM. Look at and discuss the tools and tool holders in the tool cabinet as well. Thank you.